Welcome to Mastering Solutions. In this question, let's draw a picture to start off. Okay, so here is our aperture and here's our point source. We're told that we have a screen behind this and we have a 12 centimeter wide bright patch from this. So what we have is this point source is illuminating this opening, this aperture here, and then it comes over here and we get this distance is 12 centimeters wide. We don't know what this is though, and this is what we're trying to solve for. So we'll say W for the width, and we're told that the distance to the aperture is 2 meters, and the distance from the aperture to the screen is another meter. So that means, of course, the total distance here is going to be 3 meters. Now, we'll talk a lot more about this in the next chapter as well, but an equation that is very, very helpful is talking about image height and object height to the image distance and the object distance. It's introduced in this chapter, and the equation says that the height of the image over the distance of the image is equal to the height of the object over the distance to the object. So it's really just a ratio between the two. And you can see how whatever this ratio is will be the same ratio for over here. We're trying to solve for this right here, which you can think of basically as the object height, or h, because this is the image height, and then this is the object distance and the image distance. So if we're trying to solve for h, we can isolate that by multiplying both sides by s. So h, or the object height, will be equal to the object distance times the ratio of the image, which is its height divided by its distance. So when we plug this in, we have s, or the object distance we said is 2 meters, and we're going to multiply that by the ratio, and we need to change this into meters. So the image height is 12 times 10 to the negative 2 meters divided by its distance, 3 meters. So when we come to our calculator, we have 2 multiplied by 12 times 10 to the negative 2 divided by 3 meters. So that gives us an answer of 0.08, and we're in meters, so that will be meters. So 0.08 meters. And if we convert that, we'll have 1, 2, so times 10 to the negative 2, or we have 8 centimeters. So the height of the width of our aperture after using this ratio equation here is 8 centimeters.